Greetings. In this lesson, we are going to learn about inverse functions. Inverse functions are symmetric about the line y equals x. Y equals x is this line right here. I'm going to dash it. This is the line that is called y equals x. Now, if I have a graph that has a point, let's say 0, 1, and then maybe 1, 2, maybe 2, 4, and it might look something like this. You might be saying, hey, that looks like y equals 2 to the x. If I have a graph that looks like that, then symmetric to the y-axis, or symmetric to the line y equals x, symmetric to this line, y equals x, I'll highlight it, symmetric to this, would be a graph whose ordered pairs are reversed. So instead of 0, 1, you'd have 1, 0. And instead of 1, 2, you'd have 2, 1. And instead of 2, 4, you'd have 4, 2. And it would look like that. And those would be inverse functions. The blue graph and the red graph are inverses of one another. And we can tell graphically that they are inverses because they are symmetric about the line y equals x. Now, algebraically, actually, let's continue to look at those ordered pairs. The ordered pairs have their inputs and outputs reversed. So 0, 1 becomes 1, 0. 1, 2 becomes 2, 1. 2, 4 becomes 4, 2. So that's another feature. And then, of course, there's the algebraic feature. And that's what we're going to focus on in this lesson. Also keeping in mind the graphs and those ordered pairs that they reverse their inputs and outputs. So to derive an inverse function, we're going to take these 4 steps. The first one is to change f of x to y. The second step is to interchange x and y. The third step is to solve for y. And the fourth step is to replace y with f inverse of x. Now, if you need to write all those things down, press pause and feel free to press play when you are ready to come back. So we're going to take those steps and apply them here. Our first step is to change function notation to y. So this is going to become y equals negative 5 plus 9 over 5 times x. Then we're going to interchange x and y. So this is going to become x equals negative 5 plus 9/5 times y. So where I see a y, I make it an x, and where I see an x, I make it a y. Now the third step says solve for y. So to solve for y, I need to add 5 to both sides. So the left is going to be x plus 5, and the right is going to be 9 over 5y. To get y all by itself, I'm going to multiply both sides by 5/9. The reason I'm multiplying by 5/9 is because a number times its reciprocal is equal to 1. So we'll have 5/9 times the quantity x plus 5 equals the 5's cancel, the 9's cancel, and we get y. And then our last step, I'm not sure if we wrote this. Let's look. Our last step is to replace y with f inverse of x. However, this was named g, so I'm going to change this to g inverse of x is equal to 5/9 times x plus 5. So this y became g inverse. G of x is the function. G inverse of x, that's how we say that, g inverse of x is the inverse function. And that would be our final answer. We're going to do this a few times so that you get comfortable with it. Let's try another. We've got g of x equals x plus 4. My first step is to replace g of x with a y. So we'll have y equals x plus 4. Then we're going to interchange x and y. So instead of y equals x plus 4, we'll have x equals y plus 4. Then we're going to solve for y by subtracting 4 from both sides. And I've got x minus 4 equals y, which is the same thing as y equals x minus 4. And then our last step is to change this y back into function notation. Because it's named g, we're going to use g, but this isn't g of x, this is g inverse of x. So this is the inverse of g of x, which will be x minus 4. Okay, here's one for you to try. Go ahead and press pause. And then when you're ready to check your answer, come back. And that's what I'll provide, is just the answer on this one. Okay, welcome back. You should have gotten f inverse of x is equal to x plus 4. Now, if you're looking to see where you made your mistake, you should have had these steps. And that would have given you your answer. Okay, let's try a little bit more complicated. We're doing something other than just adding or subtracting something from x. We're going to be multiplying it by 4 as well. So we've got f of x equals 4x minus 16. So my first step is to change f of x to a y. My second step is to flip the x's and y's. We also say interchange. So where I see the y's, I make it x, and where I see the x's, I make it a y. And now I need to solve for y, so I'm going to add 16 to both sides. On the left, we have x plus 16, and on the right, I have 4y. And then I'm going to divide by 4. So I'm going to divide both sides by 4. And what that means is I have y equals, this divide by 4 goes with both terms in the numerator. So I'll have x over 4 plus 16 over 4. And that's going to be f inverse of x is equal to, I'm going to rewrite the x over 4 as 1/4 x. And then I'll rewrite 16 over 4 to be just the 4 that it simplifies to be. So that's our inverse, 1/4 x plus 4. Sometimes we have to take the inverse of a polynomial function that has a higher degree. And this is an example. We have f of x equals x to the 5th plus 3. I'm going to change f of x to a y. I'm going to flip x and y. I'll subtract 3 from both sides. So I have x minus 3 equals y to the 5th. I'm going to come over here. Y to the 5th equals x minus 3. I'm going to take the 5th root of both sides. And that gives us a y on the left and the 5th root of all of x minus 3. Last step would be to change the y back to function notation. This is the inverse of f. So we're going to write f. It looks like an exponent of -1, but it really means the inverse of f. So f inverse of x is equal to the 5th root of x minus 3. Okay, sometimes we've got roots that we have to undo. So if we just follow our steps, we will make g of x a y. I'm going to move that negative to the numerator with the x so I don't lose it. I'm going to flip the x's and y's. And then I'm going to raise both sides to the 5th power to undo the 5th root. And we get x to the 5th equals negative y over 2. I'll multiply both sides by 2. I'm going to show my work up here. And I'll have negative y equals 2x to the 5th. I divide both sides by a negative. And I get y equals negative 2x to the 5th. Change it to inverse notation with a function, inverse function notation. So g inverse of x is equal to negative 2x to the 5th. Okay, let's see what we have next. Okay, see if you can give this one a try. See if you can give this one a try. If not, don't worry, just press play when you're ready to see what the next step is. Okay, the first thing I did was I changed this to y equals the 5th root of x, and then a minus 2. Then I switched the x's and the y's. And that minus 2 is still on the outside. So I add that 2 to both sides. And now I'm going to raise both sides to the 5th power. On the left, we've got x plus 2 to the 5th power. And on the right, we have just a y. I'm going to change that y to f inverse of x is equal to x plus 2 to the 5th power. And box it. So hopefully you got that. If not, maybe you can give this one a try. Same idea as the last one. This last one, we had this minus 2 on the outside, so we had to move that over before we raised both sides to the 5th power. On this one, we'll probably have something similar where we'll have to subtract 1 over before we take the cubed root of both sides. So press pause and see if you can try this one. Okay, welcome back. I made this a y equals x minus 2 quantity cubed plus 1. Then I flipped the x's and the y's. I subtracted 1 from both sides. And then I was ready to cube root both sides. So I've got the cubed root of x minus 1 is equal to y minus 2. I add 2 to both sides, so I get y equals the cubed root of x minus 1 plus 2. And then last step is change it back to function notation. The name is g, so that'll be g inverse of x is equal to the cubed root of x minus 1, and then plus 2 on the outside. So we found the inverse of different roots, of different polynomials, of higher degrees, of linear functions. Now we're going to find the inverse of a couple of rational functions. So our rational function here is f of x equals 4 over x plus 2. I am going to change the f of x to a y. I'm going to flip the x's and y's, so I have x equals 4 over y plus 2. And now I need to solve for y. So what I'm going to do is I'm going to put x over 1, and I'm going to cross multiply, so I get x times all of y plus 2 is equal to 1 times 4. So I have xy plus 2x is equal to 4. Remember, I want to solve for y. I'll highlight it. I want to solve for y. So I'm going to subtract 2x from both sides. I get xy equals I think it would be best. I think it would be best right here. I just noticed that, look, these both have an x in common. Let's get rid of that x by factoring it to the outside. And now I'm going to, instead of having something messy, I'm going to divide both sides by x, and look at how nice and neat that is. We've got y plus 2 equals 4 over x. And now all we need to do is subtract 2 from both sides. So we've got y on the left, and we've got 4 over x minus 2. And that's f inverse of x is equal to 4 over x, and then minus 2 on the outside of that rational function. Let's try another one of those. And let's do the same thing we did here. Okay, we're going to change f of x to y. Then we're going to flip the x's and y's. So x equals negative 2 over y minus 1 plus 3. I'm going to subtract 3 from both sides. So I've got x minus 3 equals negative 2 over y minus 1. I'm going to put x minus 3 in parentheses and y minus 1 in parentheses, and I'm going to cross multiply. So I have x minus 3 times y minus 1 is equal to negative 2. Now I want to solve for y, so I'm going to divide both sides by x minus 3. I'm very close to being able to solve for y now. All I have to do is add 1 to both sides, so I have y equals negative 2 over x minus 3, and then add 1. And y changes back to function notation, which would be f inverse of x is equal to negative 2 over x minus 3 plus 1. And that is our final answer. Okay, let's see if we can do one more example, and then we'll give you a try and see if you've got it. These are by far the hardest ones that you'll need to do. So having a few of these examples is great. As a matter of fact, let's go back and state what we did. So once we got here, we isolate the term that has the y in it. So once we flipped the x's and y's, so here we flip the x and y. And now in this one, we need to isolate the fraction that has a y in it. Which means I needed to subtract 3 from both sides. So that would have been subtract 3, subtract 3. And then I have this fraction that has y in it all by itself. And then over here, we cross multiplied. and divided by what? By the binomial that has an x. And then from there, you should be able to tell that, okay, now we've got y minus 1 all by itself. Add 1 to get to solve for y, and we'll be good. Okay, so the first step was, after you flip x and y, isolate the fraction with y in it. So let's get there. So we're going to change this to a y. Negative 1 over x plus 2 minus 3. Then flip the x's and the y's. Now I have a fraction that has a y in it. So I'm going to add 3 to both sides to isolate that fraction. So on the left we have x plus 3, and on the right we have negative 1 over y plus 2. I'm going to put x plus 3 over 1, and I'm going to cross multiply. So all of x plus 3 times all of y plus 2. All of x plus 3 times all of y plus 2 equals 1 times negative 1. And 1 times negative 1 is 1. So we've got x plus 3 times y plus 2 on the left, and then we have equals negative 1. Now, the last step before we got to the very, very end where we were just cleaning up was we want to divide by the binomial that has the x. So the binomial that has the x is the x plus 3. So I divide both sides by x plus 3. And we get y plus 2 equals negative 1 over x plus 3. I'm going to subtract 2 from both sides. Y equals negative 1 over x plus 3 minus 2. Last step would be change the y to f inverse. And that would be our inverse function. Okay, you go ahead and try this, press pause, and then when you're ready to reveal all the steps, the work, and the answer, come on back. So the answer that you should have gotten was f inverse of x is equal to 3 over x plus 2 plus 1 on the outside. And let me show you how I got that. I changed the function notation to y. Then I switched the x's and the y's. I added 2 to both sides. I cross multiplied. X plus 2 times y minus 1 is equal to 3 times 1, which is just 3. I want to solve for y, so I divided by x plus 2 on both sides. That gave us y minus 1 on the left equals 3 over x plus 2 on the right. I added 1 to both sides. Y equals 3 over x plus 2 and then plus 1. And the y becomes an f inverse of x equals 3 over x plus 2 plus 1. And that's how we got the answer. Now, in every single problem, we flipped the x's and the y's. So my question to you is, if these ordered pairs, 2, 3, negative 3, 6, 5, 6, 0, negative 12, and negative 11, negative 8, are ordered pairs on a function, what would the ordered pairs be for the inverse? What would the inverse ordered pairs be? So instead of 2, 3, so I don't want to reveal it until you think about it and give it a shot. Okay, hopefully you've thought about it. 2, 3 would become 3, 2. So your x becomes a y, and the y becomes an x. So you've got x, 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 x. All the inputs would become the outputs, and all the outputs would become the inputs. So 3, 2, the next one would become 6, negative 3. The next one would be 6, 5, negative 12, 0, and negative 8, negative 11. Now, normally I make several videos for one lesson. However, we were able to get through this first one because it was just so one example after the next example doing the same thing. We were on a roll, so I stuck with it. So make sure that you get practice with this so that you can remember your steps without having to go back and refer to them. Super important that you'll know what to do when asked to derive an inverse function. Thanks for watching and have a great day.